Okay, let's just get right into it. If you're out there designing, developing, or deploying AI systems, you know that managing the absolute mountain of data they consume is, well, it's totally critical. Today, we're navigating that highly complex and honestly sometimes pretty overwhelming intersection of artificial intelligence and data privacy. And we're going to do this through the lens of a really powerful new international framework. We're talking about the ISO/ISE 42001-2023 standard. Our goal for this explainer, we're going to break down exactly how you execute robust privacy and security measures so your AI isn't just smart, but it's safe and compliant.
It's a pretty heavy question to kick things off, right? Is your AI system a privacy liability? Because if we look around today, the digital landscape is honestly a bit chaotic. I mean, we constantly hear these stories of AI privacy failures. We're talking massive data breaches exposing sensitive personal information, adversarial attacks manipulating algorithms, and that deep-seated algorithmic bias causing real-world harm. The stakes here literally could not be higher. If you're building an AI system without a structured governance framework, you aren't just risking a few operational hiccups. No, you are risking severe legal consequences and ultimately, a complete loss of public trust.
Okay, let's dive into this. To secure these incredible AI systems, we're going to rely on what we can call the 5 pillars of protection from the ISO standard. That's privacy by design, executing DPIAs, AI encryption, algorithmic explainability, and finally, global compliance. These are going to serve as our roadmap today.
Let's transition right into our very first pillar, privacy by design.
See, data privacy simply cannot be an afterthought. It's not just a patch you slap on right before you launch. It absolutely must be baked directly into the DNA of your AI system from day one. By definition, privacy by design and default means you are integrating those privacy protections from the ground up. Before a single line of code is written to train your AI model, the architecture for privacy has to already exist. The ISO standard essentially requires that security controls and risk mitigation aren't just features, they're foundational elements. It shifts privacy from a reactive, scramble, to a proactive strategy.
And this brilliantly illustrates the 4 core tenets of privacy by design in practice. First up, you've got to identify privacy risks early. We mean during the design phase, not when you're already in beta testing. Second, you absolutely must enforce strict data minimization. Just collect the absolute bare minimum amount of data your system actually needs to function, period. Third, you enable data anonymization and pseudonymization to completely strip away those personal identifiers. And finally, ensure operational transparency so your users know exactly what is happening behind the scenes.
So let's ground this in reality with an example. Imagine an AI healthcare app that's designed to predict patient outcomes. Under privacy by design, this app is hardwired to only collect the essential health metrics required for that prediction. So no unnecessary location tracking, no scraping their phone contacts, none of that. Plus, all the medical records fed into the training data are fully anonymized. The actual identity of the patient is completely separated from the medical condition. This is what makes those abstract principles we just talked about feel grounded and extremely urgent.
Moving on to our second pillar, executing DPIAs.
Now, if privacy by design is the underlying philosophy, the Data Protection Impact Assessment, or DPIA, is essentially your ultimate risk mapping radar. Let's move to and see how this builds a highly procedural safety net through 4 clear steps. Step 1 is data mapping. Here you identify exactly what types of data your AI is processing, keeping a really close eye on sensitive, personally identifiable info. Step 2 is risk identification. This is where you actively hunt for vulnerabilities, like unauthorized access or algorithmic bias. Step 3 is risk mitigation, where you implement measures, like encryption, to neutralize those specific threats you just found. And Step 4 is consultation. Sometimes, especially when you're dealing with high-risk AI, you actually need to consult directly with data protection authorities before you even think about hitting deploy.
To see how this plays out, consider an AI recruitment tool that filters through hundreds of resumes. A DPIA forces the organization to actually map out that candidate data and proactively identify the very real risk of gender or racial bias based on, say, historical training data. Then it forces you to mitigate that risk before the tool ever goes live. Essentially, it ensures you catch the bias before the bias catches you.
That brings us to pillar number 3, AI encryption.
Now, what's really interesting about this slide is how it frames encryption as your technical shield when you're managing vast lakes of data. Notice the crucial distinction between these 3 specific types here. You have at-rest encryption, which secures data while it's just sitting there in your storage databases. Then we have in-transit encryption. That protects data as it moves across networks, like traveling from a user's smartphone over to a cloud server. But the real game changer for AI, the truly exciting part, is that third row, homomorphic encryption.
Let's just spend a second on homomorphic encryption, because it is genuinely fascinating. This is an advanced, specialized form of encryption that allows an AI model to actually perform computations on encrypted data without ever decrypting it first. It's wild to think about. Think of it like a master jeweler working on a priceless diamond, but the diamond is stuck inside a locked, impenetrable glass box. The jeweler can shape and alter that diamond using specialized tools built right into the box, but they never actually touch the gem itself, and the box is never opened. So the AI learns and calculates without ever seeing the raw sensitive data.
You can absolutely see how critical this is for high-stakes deployments. Take an AI financial platform that's analyzing customer transaction histories, for instance. It must use encryption at rest in its databases, in transit across the network, and potentially even homomorphic encryption during the AI's risk calculations. This guarantees the customer's financial data is completely shielded from any unauthorized access or breach throughout the entire life cycle.
Transitioning now to Pillar 4, algorithmic explainability. This directly addresses the notorious black box problem we see in AI today. As these AI systems become increasingly complex, their decision-making processes just get harder and harder for humans to understand. We're looking at a stark contrast here. On one side, you have black box AI, where decision-making is opaque, it's hidden, and frankly, it's unaccountable. Contrast that with explainable AI, which the ISO 42001 standard strongly advocates for. This means transparent algorithms, understandable logic, and auditable trails. Think about your own deployments for a second. If an auditor, or even just a curious customer, asked exactly how your AI arrived at a specific decision, could you actually tell them? If your system is a black box, the answer is no. And honestly, that is a massive privacy liability.
So the crucial point is that organizations have to take actionable steps to shatter that black box. You literally have to maintain incredibly clear documentation on your algorithmic logic and your model lineage. You must be able to provide simple, understandable explanations to your everyday users. You also need rock-solid mechanisms for accountability, so you know exactly who is responsible for the AI's output. And finally, you absolutely must conduct regular, rigorous audits to constantly test for fairness and bias. Grounding this explainability requirement again, think of an AI credit scoring system. If someone is denied a loan by an algorithm, they have a fundamental right to know why, right? Explainable AI ensures that the bank can actually provide the user with a clear, understandable explanation of the specific data points and the exact logic the AI used to make that denial. It builds trust, and obviously, it keeps you legally compliant.
Which brings us to our fifth and final pillar, global compliance. This is where we take all of those technical practices we just talked about, the encryption, the explainability, the DPIAs, and connect them right back to global legal alignments. The ISO/IEC 42001 standard acts as a phenomenal bridge to help you navigate massive regulatory frameworks, like the GDPR in Europe and the CCPA in California. To actually be compliant, your AI governance needs to feature robust user consent management. People have to opt in clearly. You must uphold data subject rights, meaning a user can simply ask to access, correct, or outright delete the data your AI holds on them. And internally, you have to strictly enforce role-based access control, or RBAC. This ensures only authorized personnel can access the highly sensitive data that's driving your AI models.
Our source material lays it out perfectly. Organizations must ensure that their data governance practices comply with applicable privacy laws and regulations to maintain trust and mitigate reputational risks. I mean, it really is that simple. This isn't just about checking a legal box to avoid some hefty government fine. This is about maintaining the fundamental, unshakable trust of the users who rely on your technology. Because once that trust is broken by a careless AI system, well, it is incredibly difficult to ever earn back.
Which brings us right to our final thought for this explainer. If your AI systems were audited today, like right this second, would your data privacy hold up to the standard of ISO/IEC 42001-2023? Do you actually have privacy by design? Are you executing DPIAs? Are your algorithms truly explainable? I know it's a challenging standard, but implementing it is the absolute key to building AI systems that aren't just powerful and innovative, but are deeply responsible, incredibly secure, and completely ready for the future. Thank you so much for diving into this explainer with me, and definitely keep learning.